I'm your host, Yivi. If you enjoy the channel, please like, subscribe, and share. In a landscape defined by relentless innovation and competitive spirit, the field of artificial intelligence, AI, has once again been shaken by a major announcement. On January 2025, Alibaba, a titan in the global tech industry, unveiled its latest advancement, the Qwen 2.5 Max AI model. The timing of this release underscored the urgency and competitive tension prevailing in the AI domain, especially against the backdrop of an aggressive rise by the Chinese startup DeepSeek. Alibaba's claim that Qwen 2.5 Max surpasses the celebrated DeepSeek v3 model, as well as top-tier models like OpenAI's GPT-4o and Meta's Llama-3.1-405b, has added another layer of intrigue to the rapidly evolving AI landscape. These assertions not only generate headlines but also have significant market implications, influencing stock performances and strategic directions for companies worldwide. DeepSeek, a relatively new entrant in the AI space, has had a remarkable impact within a short span, challenging long-standing industry norms with its cost-efficient and high-performance models. The stakes are high, and as advancements continue to emerge from both startups and established companies, there is a pressing need to measure AI model competence systematically. The challenge lies in navigating through marketing claims to discern genuine technological superiority and understanding the practical implications of these advancements. This article aims to explore this vital aspect by delving into the frameworks and metrics used for evaluating AI model competence. Our discussion will encompass existing benchmarking practices, the inherent challenges in model assessment, and suggestions for developing a robust evaluation framework. Through this analysis, we aim to illuminate how objective measurements can guide strategic developments and market positions, ensuring that stakeholders can accurately assess the capabilities of burgeoning AI technologies in an ever-competitive arena. By understanding the dynamics at play in this case study of Alibaba and DeepSeek, you can gain insights into broader trends and challenges within the AI domain, setting the stage for discussions on the future of AI model development and deployment. The development of large language models, LLMs, represents a quantum leap in AI capabilities, fundamentally transforming how machines interact with humans. LLMs, such as GPT, BERT, and now DeepSeek v3, function by leveraging vast datasets to perform an impressive array of tasks, from answering questions to generating creative content. The technological backbone of these models is the use of transformer architectures that allow them to understand and generate human-like text through nuanced comprehension of context. The global landscape of LLM development is rich with key players, both established and emerging. Companies like OpenAI, Google, and Meta from the United States have led many innovations in this field. Meanwhile, the rise of Chinese tech giants, such as Alibaba, Tencent, Baidu, and now the startup powerhouse DeepSeek, signifies an oriental shift in AI dynamism. These Chinese models are not only catching up but often exceeding their Western counterparts in areas like cost-effectiveness and efficiency, posing a substantial challenge in the competitive AI environment. This evolution of LLMs is facilitated by the convergence of massive computational power, expansive data availability, and intricate algorithmic advances. As a result, LLMs have penetrated various industries, from customer service automation to complex problem-solving in scientific research. With the growing influence of Chinese-developed models, there has been increased pressure on global players to adapt and innovate continuously. The models from China, typified by DeepSeek, are characterized by aggressive pricing strategies and open-source accessibility, democratizing AI usage and development globally. Understanding the development and deployment of these models sets the stage for comprehending their market impact and the necessity for an objective assessment framework to evaluate their true capabilities and contributions. The announcement of Alibaba's Qwen 2.5 Max, with claims of outperforming DeepSeek v3, sets an exemplary scene of technological rivalry. Alibaba, a conglomerate with vast resources, seeks to cement its position through groundbreaking innovation and strategic responses to the competitive landscape shifts initiated by DeepSeek. DeepSeek v3, however, represents more than just an advanced AI model. It embodies the agility and disruptive potential of startups in technology-driven sectors, having left a remarkable impact through its R1 model's outstanding benchmarks. DeepSeek's rise has been meteoric, catalyzing competitive dynamics both domestically and internationally. Its appeal lies in the blend of high performance and low operational costs, making it a formidable competitor to traditional tech giants and emerging models from companies like ByteDance. This case study exemplifies how the competitive edge in the AI model race is increasingly defined by nuanced performance evaluations rather than mere quantitative output. Analyzing the claims made by Alibaba regarding Qwen 2.5 Max requires a detailed examination of performance metrics, benchmark standards, and the practical implications of these advancements. By scrutinizing these aspects, we gain insights into the model's real-world efficacy, guiding strategic development and market adaptation. The significance of this competition extends beyond technical prowess to influence market dynamics, pricing strategies, and potentially even global technological leadership. As we decode the ongoing battles between Alibaba and DeepSeek, we underscore the urgent need for a robust framework to objectively assess AI model competence. As AI language models proliferate, the challenge remains: how do stakeholders effectively measure and compare these models' capabilities? The quest for an objective evaluation framework is critical, aiming to sift through myriad performance claims to establish factual, reliable insights into a model's strengths and weaknesses. Current practices involve using benchmarks such as AMI, GLUE, and SQUAD datasets, which provide standardized tests assessing models' ability to understand and process complex instructions. These benchmarks offer a window into the model's linguistic comprehension and application agility. However, these evaluations, often characterized by their static nature, may not fully encapsulate the dynamic and multifaceted capabilities of modern LLMs. Qualitative assessment involves evaluating the complexity of tasks a model can handle, the adaptability to diverse language nuances, and success in real-world applications. In contrast, quantitative measures focus on aspects such as speed, accuracy, processing power requirements, and cost efficiency. Balancing these approaches can lead to more comprehensive insights into each model's competence. Furthermore, model evaluation must consider ethical dimensions, such as biases in data and decision-making processes. An objective framework would thus lean on large-scale collaborative efforts among academia, industry, and consortia dedicated to setting evaluation standards. This collaboration ensures holistic assessments that include technological brilliance and broader societal impacts. Building such a robust framework not only positions models competitively on the global stage, but also guides research and development alignment with real-world needs, embedding sustainability and accessibility at the core of AI advancement. This will facilitate advancements towards a more informed and balanced AI ecosystem. Constructing an objective measurement framework for AI models requires careful consideration of various performance metrics. At its core, the evaluation should encompass technical capabilities, practical functionalities, and the model's ability to foster incremental innovation in technology ecosystems. Key components for such a framework include metrics like speed, accuracy, and processing power efficiency. Speed can be measured by how quickly a model processes input and generates output, a critical factor for real-time applications. Accuracy is assessed through tasks that determine how well a model adheres to facts-based scenarios or achieves defined outcomes. Processing power efficiency addresses the computational load required to execute tasks, reflecting cost-effectiveness and responsiveness. Furthermore, the complexity of tasks a model can handle should be evaluated, as well as adaptability to language nuances or diverse linguistic contexts. Adopting a structured testing method that simulates real-world scenarios will better illustrate how models perform outside controlled benchmark settings. Comprehensive evaluation also accounts for a model's ethical and social repercussions, ensuring AI development aligns with principles of fairness and transparency. In scenarios where AI has socio-economic implications, assessing models through multidimensional benchmarks suggests a commitment to maintaining ethical standards across AI applications. The goal of this framework extends beyond mere comparison, encouraging progressive and innovative strides that leverage AI's potential while safeguarding ethical use and societal benefit. Encouraging collaborative input into this framework can create standardized benchmarks for fair and comprehensive model assessments. Ultimately, this framework acts as a guidepost for aligning AI development with strategic, societal, and technological goals. In the quest to objectively evaluate and compare AI models, several benchmarking methods have emerged as industry standards. These benchmarks serve as crucial tools, providing a consistent framework to assess the capabilities and performance of AI across various tasks and domains. Here is an overview of some prominent benchmark methods. GLUE, a comprehensive suite of tasks designed to test a model's ability to understand and process natural language. It includes diverse tasks such as textual entailment, semantic similarity, and sentiment analysis, challenging models with linguistic phenomena that mimic real-world language use. Superglue, building on GLUE's foundations, Superglue offers a more challenging set of tasks focused on reasoning and contextual understanding, advancing the abilities of language models. SQUAD, evaluates AI models on their ability to comprehend and answer questions based on a given text, making it a critical benchmark for applications in customer service and education. ImageNet. Essential for computer vision, this benchmark offers a large-scale image dataset for evaluating model accuracy in classification tasks, driving advancements in visual recognition. COCO. As a benchmark for object detection, segmentation, and captioning, COCO tests models on their ability to provide rich, contextual insights into complex scenes. Lambda focuses on language comprehension and prediction, evaluating a model's ability to predict the final word of given sentences, thus measuring contextual understanding. OpenAI AI Gym. While primarily associated with reinforcement learning (RL), AI Gym offers diverse environments that help benchmark AI behavior in simulated tasks, valuable for robotics and autonomous systems. AMI focused on models' ability to understand and respond to complex instructions, offering additional insights into adaptability and reasoning capabilities. These benchmarks, while primarily serving to measure performance, also stimulate innovation by offering clear targets for AI researchers and developers. By continually testing AI capabilities against these rigorous standards, the industry can drive improvements that bring models closer to real-world applicability and performance excellence. As AI technology continues to advance, these benchmarks evolve, ensuring they remain relevant and challenging amidst the shifting landscape of AI capabilities. This ensures that AI models not only meet current demands, but also anticipate future requirements in an evolving range of applications. Industry-specific benchmarks present an opportunity to tailor AI model evaluations to meet particular sector needs. By developing customized benchmarks, industries can better assess how AI models perform relevant tasks with precision and efficacy. For instance, in healthcare, AI evaluation might focus on diagnostic accuracy, predictive analytics, and patient data interpretation, determining models' applicability and safety in medical settings. Similarly, in finance, benchmarks would center around models' ability to analyze market trends, manage risks, and ensure regulatory compliance, providing insights into robustness and agility. Creating these industry-specific frameworks involves collaborations with domain experts who can identify the sector's unique challenges and opportunities. This collaborative approach ensures models are tested against relevant criteria, making them more reliable and suitable for industry applications. The role of open source in benchmark development cannot be overstated. Leveraging open source frameworks allows industries to build transparent and adaptable benchmarks that foster community-wide trust and participation. This approach encourages shared learning and innovation, bringing diverse insights to refine benchmarks and elevate AI model evaluation. These tailored evaluations prompt a constructive iterative loop of feedback, guiding AI model enhancements and ensuring their alignment with practical industry demands. Through such specificity, models gain validation for industry entry and build stronger connections with real-world functionality and usability. As the landscape shifts toward more nuanced model deployment, these targeted benchmarks ensure that AI tools are not generic solutions, but finely tuned instruments designed to meet specific industry needs effectively. As the AI model landscape evolves, the manner in which competence is measured can have profound effects on market dynamics. Comprehensive evaluation frameworks can bolster or destabilize market positions, influencing adoption rates, pricing strategies, and R&D directions. An objective measurement framework, when trusted by industry players, becomes a valuable tool for informing purchasing decisions and model integration into business processes. Companies that demonstrate high benchmark scores and model proficiency reap significant rewards as purchasers prioritize proven capability over marketing hype. This endorsement typically translates into greater market share and competitive leverage. Market dynamics also shift in response to pricing structures impacted by evaluation. As models are assessed against standardized benchmarks, pricing can reflect not just costs but value measurable by real-world effectiveness and capability reach. This valuation transparency can democratize AI access, motivating broader deployment across diverse sectors regardless of previous technological capital. Furthermore, media portrayal of AI models is influenced by objective evaluations. As stakeholders and industry observers rely on rigorous assessment outputs, media narratives are molded by data-driven insights, making media influence a factor of informed assessment rather than conjecture. The interconnectedness of these factors outlines the tremendous influence of model evaluation on technology markets. By ensuring accurate, comprehensive, and ethical assessments, the AI landscape stands to benefit from enhanced transparency, trust, and technology diffusion, fostering dynamic, competitive innovation while driving advancement forward. Despite advances in AI evaluation, challenges persist in ensuring accurate and reliable competence measurement. At the forefront is the issue of standardization across models, presenting an enigma given the diversity in model architectures, training methodologies, and application areas. The rapid pace of innovation complicates efforts to maintain cohesive evaluation benchmarks that stay relevant across evolving technologies. Models with differing objectives and datasets may require distinct evaluation criteria, challenging the development of universal frameworks. Moreover, balancing innovation with stringent testing protocols is crucial. While testing must be thorough to maintain integrity, excessive rigidity can stifle creativity. Encouraging a dynamic framework that is flexible enough to incorporate new challenges yet rigorous remains a critical goal. Ethical concerns add another layer of complexity, demanding focus on fairness, accountability, and bias avoidance in model evaluations. Addressing these concerns requires multifaceted benchmarks that account for societal and ethical impacts alongside functionality metrics. Cultural considerations further compound the issue. AI evaluation frameworks must transcend local biases to ensure equity and fairness across diverse global applications, presenting challenges in achieving universally accepted standards. Despite these challenges, ongoing collaboration among academia, industry, and regulatory bodies offers pathways to overcome hurdles. By fostering a culture of openness and adaptability, the AI community can continue evolving measurement practices to create robust, trustworthy, and adaptive frameworks suited to rapid technological evolution. As AI technology matures, future directions for model evaluation tend towards greater openness, collaboration, and complexity to understand comprehensive capabilities and potential. Emerging trends include open-source benchmarks reflecting an ecosystem where openness fosters confidence, and collaborative input ensures diversity in evaluation criteria. Innovations in evaluation methods bring forward simulations of real-world scenarios and multi-dimensional evaluations, grasping the subtleties of nuanced cognitive problems that AI models increasingly face. By simulating complex environments, evaluations can more accurately reflect performance and adaptability in experiential and context-rich tasks. Ongoing efforts to understand artificial general intelligence, AGI, focus evaluations on models' progression toward human-like cognition across diverse economic settings. The challenge lies in creating benchmarks that capture human-like problem-solving capabilities, targeting AGI's approachability and reality. Long-term implications suggest an evaluative emphasis on ethical, social, and environmental considerations. As responsibilities intertwine with capabilities, aligning AI advancements with human values remains paramount. Collaborative frameworks incorporating stakeholder voices across sectors and geographies help anchor AI developments within these essential ethical dimensions. Ultimately, future models may transcend traditional assessment conventions, grounding evolution in both technical excellence and societal impact. Data-driven advancements, balanced with accountability, will embody broader, holistic measures of model competence. As AI's significance expands, the precision in evaluating AI models becomes imperative to their developmental trajectory and ensuring informed stakeholder decisions. Understanding and implementing robust, objective frameworks, industries can cement pathways for innovation, simultaneously tempered by practical utility and ethical grounding. Enhancing these measurement standards promises to elevate transparency, competition, and responsible technology deployment, guiding AI models toward meaningful, sustainable integration into society's technological fabric. As the case of Alibaba and DeepSeek illustrates, model evaluation transcends corporate rivalry, contributing to a future where AI thrives under precise, accountable, and forward-looking stewardship. This comprehensive approach will redefine AI engagement, fostering an ecosystem where collaborative models and ethically sound advancements lead to enriched societal and economic endeavors, shaping the future of AI in groundbreaking and holistic ways. If you enjoyed today's discussion and found it valuable, please subscribe to the podcast, leave a review, and share it with your community. Until next time, stay curious and keep innovating. I'm EV, and this is I Forever, Establishing Smart Living.